This is a Digibarn Alto 5-volt power supply, and I have never seen a power supply with that many faults in it. We have been battling it for days and it's still not up. So here's a bunch of failed components we found in it. So it started by blowing its fuses in spectacular fashion. I don't know if I can show you this one, but it was more an explosion than blowing a fuse. And then of course we went straight for the capacitors. Maybe they have too much inrush or they are short. Actually none of them looked okay, so we replaced them all. We had to buy equivalents and they're pretty costly. And then it kept on blowing fuse, so that was not only it. And pretty soon, so we don't have the schematics for this, which makes it even tougher. But we didn't have to go very far, right? Because out there are 4 diodes, rectifier diodes, and 2 of them were shorted. They are pretty sturdy diodes. Those are 800-volt diodes. So we got those ones changed. And now it doesn't blow fuses anymore, but it's still not up. So then we start to measure voltage of the control section. There is no voltage. So out there somewhere at the back there's a voltage regulator. You can see it right in the middle on the heatsink. My fingers behind it. And that guy reads 0 volts. Okay, so off it goes, we change it, and turns out it's still bad because the output's shorted. And then we get the classic shorted tantalum, which we found by just basically powering it with several amps, and we look for the smoke. So while we were at it, we changed a few more tantalums also. Only one was bad. Still not up. Then we see that this guy might be leaking, but I don't think it was. I think it was just glued and we missed the glue for leaking, and okay, we changed it. Still not up. So what else can we do to get this one up? Alright, so okay, now at least I have 5 volts at the back in my control section over here. And I took some internal fuses out so I can check if it's chopping. So I'm hooked up at the base of one of the power transistors. I haven't hooked the ground because I don't want to fry anything. So you see some 60 Hz, but if it chops, it should, it's AC couple, it should do something. And when I put it on, nothing. There is no chopping action. So the control circuitry is not working. So I was sniffing around just to try to find if there's any evidence of something oscillating at the right frequency, and I found one pin here that has something. The first sign of life I have on that power supply. Measure frequency 23 kilohertz. Yes, that would be it. Okay, so if I have that, that's the chopping frequency. So if I have that, I have to figure out why it's not coming out. I've been following my signal around. I found a chopper signal who makes it to the next gate, but somehow never comes out. So here's my chopper signals cannot come out at this gate. It's blocked because this is low, and then you trace it all the way back and it's driven by that other circuit here all the way to the side. Where are you? I can't see it really. It's behind this right here. And this guy is a multi-vibrator and the pin is always high. So I was wondering if it's triggered, and so you look at the trigger input, and let's see if I can get to it. Is that transistor back there? Poink. And yes, it is triggered. So it's triggered every 22 microseconds. So this should multi-vibrate unless the pulse is too long and it gets re-triggered. So here's the circuit I have traced so far. So first I found my chopper signal that came into the NAND gate and never came out because it was blocked by the other pin of the NAND gate, which was always low. Then you follow it to the transistor, so that guy was always high. And then I came to the 754-122 multi-vibrator, which output was always high. And then I looked the condition to trigger it, and actually most of the conditions are ignored. They are tied to the VCC, and it should trigger on a down pulse over here on the two A inputs. And I looked on the scope, and it looks beautiful, like it should be triggered repeatedly. But unless it's re-triggered too quickly, this should go down sometime. And I calculated, so that I might be wrong, but if it's right, it's 3.8 microsecond, and it's triggered every 19, so it should have ample time to reset. And this guy should go low repeatedly and let the chopper signal go through, but it's not. So either I calculated my pulse wrong, or the 74-122 is bad, or is something else that I don't interpret correctly, which is very probable. Okay, old circuit is out, and I solder a socket instead and remove the capacitor. I'm not using the high voltage supply right now, so I made a little bit of room here so it's easier to access. Let's see if that multi-vibrates better. And nope, no cigar, still staying high at the output, still being triggered, and don't understand why. Okay, finally I have my multi-vibrator behaving as it should. And I thought I was going mad. So here oh, well, it's not turned on. Here is my output, and it has the nice pulses going through it. My signal finally goes through the gate. Here it is, and it's going to, at least a square wave, as I get it, there we go. And it's going to the amplifier on the base of the transistor. I'll have some chopping action if I put back the high voltage, I guess. And what had happened is that I didn't see, but in the circuit here, they had added a little resistor that's part of either a shutdown circuit or most probably the regulation. And I just took it off. There it is. So these are the resistor, the capacitor and resistor I expected to do the 3 microsecond pulse. But it was all screwed up because this resistor was in and was preventing it from doing this monostable impulsion. And so now that I've taken that out, it works as it should finally, and I'm not crazy, and my two circuits behave the same. But I probably have screwed up the regulation system somewhere. So let's see, at least if I remount the high voltage, I'll see if I have some 5 volts coming out. Okay, moment of truth, or I might ruin the whole thing. I've put the high voltage back, the fuses that connected to the power transistors, and see if we have some regulating action. I'm kind of sort of ready to turn it off really quick if I need to. Yeah, 11 volts. Yep. Right. So that's what I expected. That now I have voltage at the output, but it wasn't regulated. Okay. Let's try it again. I have my lights connected to it, so okay, see if there's transistors. These are getting hot. And I was so happy I finally got something. I plugged it a little bit longer in and it started to blow its fuses pretty violently. I believe the transistors are no more transistors. They didn't really like to be operated in with a regulation loop opened. Rats. Now I have to figure replacements for these. It's a solitron transistor. Never heard of it. 13SE150. Apparently an aerospace part. And here's a good one I took from another supply. That's what it's supposed to be. So here's the one I just pulled out of the supply. Oh, yes. It's not a transistor anymore. So I'm curious to find out what went wrong with it, so I'm going to try to open it up. Alright. No visible damage. It's the bad one. I was worried for a second. Okay, I have it under the binocular now, and you can tell what the problem is. If I can ever get a shot of it. There we go. And look at that beautiful crater down here. This is where the emitter lead is. That's the base. That's actually, there are two emitter leads. So just overcurrent most probably. So that's going to make my life more difficult if it blows transistors when the regulation part doesn't work. It's going to be pretty difficult to debug without blowing a few. And then the thermal compound under the mica plate has completely dried out. Oh, two of them. Okay, new transistors. I have closed the regulation loop again, so I expect not to have any output. Oh, that made some noise. Oh, 5 volts. Voltage is adjustable. It is. Okay. I think I know where the weird noise comes from. I think it comes from that resistor right here. Is that resistor there? And look at it. It looks like it's broken. I don't know if I can zoom on it and maintain focus. I can zoom on it but not maintain focus. Oops, there is not much space. This is so weird. Comes from over the place. Darn, I zapped my transistors again. And this time I was trying to look for the origin of the sound and if it was correlated with the chop pulses. And then I put my probe right into those two pins of the IC, which would bring the chopping signals to a continuous plus for a very short amount of time. And the transistors just can't take it. They can't pull the current through the coils continuously. They just instantly went bad. And now I have this unobtainium transistors I need to replace. I suppose is just a high voltage, high current NPN transistor. I know it's an NPN transistor because I took some traces of it. So I'll try to get the modern 400 volt transistor or semi-modern 400 volt transistors. I found one in my collection I think will work. This is a 2SC2429, advertised as a pretty sturdy 400 volt transistor, 10 amps. I put one on the curve tracer, and that's where having a good curve tracer that goes to high voltage pays off. So let's see, oh, that's a beautiful transistor. And this is up to, this is 50 volts per division, so 100, 200, 300, 400, so it passes here. And let's try even a little further, see if it curves up. So go to 1600 volts maximum, don't touch the transistor, or you'll be zapped. Here we go, and there you go. So you can tell where it's curving up. 1, 2, 3, 4. Yeah, so it's a good 400 transistor. It's 400 volt transistor. And if we want to trace the gain, I discovered there's a mode I didn't know about. I go put this one on step gen. Here we go. And then you have a beautiful base versus collector current. So the gain is a little bit over 20, which is plenty fine. Okay, new Fujitsu transistors are in. I put 2 new fuses in because when the transistors go, then the fuse kick in, but too late after the transistors are short already. So, moment of truth, watch it. If the transistors blow, you'll see it from the fuse. It'll be a nice display. 1, 2, 3, go. Aha! It's more than 20 volts, something's wrong. I heard the right, where is that? Oh, I'm on the wrong setting here? No, it's not regulating properly. I hear the sound of the choppers. There you go, 5 volts. Alright, so it looks like those transistors are doing fine. Lot less noise from the supply. It's much quieter. And by the way, just for kicks, this is the quote I got from one of those many shady places that come up when you look up part numbers, and they promise that they'll find an old part for you, usually a military or aerospace qualified part like this transistor is. And they sure can get me 2 of them for the ridiculous price of $610. So you can view it 2 ways. I either saved a lot of money by replacing them with what I think are better transistors, or I blew up very expensive transistors. But I think it's unfortunately the former, and those guys just take advantage of your tax dollar money by selling those components, mostly those old worthless components, mostly to the government. Because that's what they have qualified in their piece of military or defense equipment, and they want to replace same for same. But wait, there's one more part that I haven't tested, and actually Al thinks it could be the root cause of why there's so many bad components. It's the that have failed into this power supply. It's the fan, and actually I think it's onto something. It doesn't turn, it doesn't spin very freely here. So I've reconnected it, and let's see if it spins any. and it does not. Ugh. So fortunately, one more component that comes from the donor non-alto power supply. Here we have a good fan. And that's how it should do. Pretty sturdy power supply it has. 5 volt 60 amps. This is the real test. We're going to try 60 amp on the power supply. Right. And so 0, that's 0. I put it at 10 amps. 10 amps, 4.89 volts, 98 actually. So it's good. 40 amps. And then
Are the wires getting warm at all?
50 amps. No, I don't leave them long enough. I'm being very gentle. 50 amps, 4.98 volts. But it has quite a nice 4.98 volt over here, and it's 4.5 over down here, so it's feeling it. And then for the last one, not 66 amp cannot be done. 60 amps, which is the most my load can take. Ready for the flames, and it works. It is 4.3 here, but it regulates it to.
So it must be like 10 ohm cable.
Right. 60 amps? No, not that much. 1 ohm. Right. Okay, well, I think I repaired it, guys. Then I can remove the original stickers we put on it. It said dead. It's not dead anymore. And it blew its 12 amp fuse, and it doesn't blow any fuses anymore. Well, that was one of the most difficult power supply restoration I've done. And back there is the incredible pile of bad parts that came out of it. 4 power capacitors, 5 electrolytics, a lot of fuses blown, tantalums that are shorted, bad resistors, shorted diodes, a bad regulator, 4 blown transistors. Well, at least 2 I am responsible for, so we'll give them a break on that, but still, that's a lot of bad parts for just one supply.
Ready?
I'm ready. Oh! Magic smoke escapes? Yeah, it's from, where is it from?
I think it's that disc capacitor.
Is that, yeah.
RT1 and RT2.
Would that be this? This is our first magic smoke event in an Alto. And this is where the magic smoke escaped from.